All right, we are down to our last topic for before the midterms. Now, um, previously we've discussed about the um, what you call this environmental waste wastewater engineering. So, we already know how to mitigate water pollution. Now, how about the quality factors and the water quality factors and parameters? All right. So, what are the quality factors and parameters to determine whether our water or bodies of water are have pollution? All right. So, in measuring the water clarity, so first off is turbidity. So, turbidity is a measure of the degree to which the water loses its transparency due to the presence of suspended particulates. Particulates. So, mura siya og kanang if ang tubig kay lubog or dili lubog. So, that's in Visayan terms. Alright, so a turbidity measurement could be used to provide an estimation of the TSS. So previously, kato atong gi-discuss last meeting. So I've mentioned TSS. So this is what you call the total suspended solids. Now turbidity, you can correlate with the TSS. So what causes turbidity? So there are various So, what are the ways to measure turbidity? So, turbidity is measured in NTU or nephelometric turbidity units. The instrument used for measuring turbidity is called a nephelometer. You can also use a colorimeter, which uses the color of your sample, or turbidimeter, which measures the intensity of light scattered at 90 degrees as a beam of light passes through a water sample. So, iyang gina-measure kung how much of the light is absorbed by the sample and how much of the light passes through the sample. So, in lakes or bays, turbidity is measured with a Secchi disc. Secchi. Alright, so what are the turbidity values? So again, I've mentioned that it is measured in NTU or sometimes FTU, which means Forel turbidity units. So no suspended solids present is a value of 0 NTU, while drinking water should be no more than 5 NTU. Alright, kung walay solids present, it is 0. While drinking water should only have a turbidity value of 5 NTU. So just like this, no? So this is the sediment plume of the south shore of a lake. So as you can see here, naa siya noticeable change in color. So that's what turbidity is. So sometimes when the water is so turbid, so less light passes through, and so aquatic or marine life is affected. So TSS and turbidity are two common measures of the concentration of suspended particles. So suspended materials influence the water transparency, the color, and again, I've mentioned earlier, the overall health of the ecosystem and the nutrient and contaminant transport. Now let's move on to alkalinity and hardness. So, what is alkalinity or hardness? Alkalinity is a measure of the ability of water sample to neutralize a strong acid. So it is expressed as milligrams of calcium carbonate per liter or microequivalents. So alkalinities in natural waters usually range from 20 to 200 milligrams per liter. So from this, no, alkalinity is basically um, it's like a measure of pH, but it's not really pH. But then, how could the water be neutralized with a strong acid? All right. While hardness is a measure of total concentration of calcium and magnesium ions. So it is also expressed as mgCaCO3 per liter. So why do we need to measure alkalinity and hardness? So the alkalinity of natural waters is usually due to weak acid and ions that can accept and neutralize protons, mostly bicarbonate and carbonate in natural waters. So usually expressed in units of calcium carbonate. So the ions, calcium and magnesium, that constitute the hardness are necessary for normal plant and animal growth. So hardness may affect the tolerance of fish to toxic metals. So sometimes if taas na kayo ang calcium and magnesium, then it affects how the fish can tolerate toxic metals. It also affects greatly the marine life because calcium and magnesium are also nutrients to marine life. Next is we have the colorimetry and spectrophotometry. So one useful and often used way of determining the concentration of a chemical in a solution if it has a color is to measure the intensity of the color and relate the intensity of the color to the concentration. So, ang color sa isa ka sample, pwede na siya correlate with the concentration of a certain chemical. So, that is being used in water sampling. So, let's review a little bit. Now, in the principle of light, so visible light is part of the electromagnetic spectrum with a range of 350 to 720 nanometers. Now, as you can see in the diagram, so we have the gamma rays, X rays, the ultraviolet rays. Those are below the visible light. Now, we also have above the visible light, which is the infrared rays, the radar, FM, TV, shortwave, and AM. So, those part of the electromagnetic spectrum is invisible. So, as you can see also below, the diagram for the visible light. So, from if you know the parts of the rainbow, so that is what it's there. So we have the red to orange to yellow to green to blue, indigo, then violet. All right. So, the sensitivity or the human eye sensitivity affects the color, all right? Even the intensity of the color. So, this is what a colorimeter looks like. So, it is to analyze the intensity of chemical reactivity. So the results are direct reading. So the sample, mo siyang ibutang diha sa isa ka sampling tube and you put it inside the tester. Alright. So what are the features of the colorimeter? So the entire multi-LED optical system is embedded in the light chamber and optimized for Lamotte test reagent system. So it also has wavelengths that are set and can standardize with sample water and run multiple tests. Alright, so how does the colorimeter work? So it focuses on the following wavelengths of light. We have the 430, 520, 570, and 620. Alright, so remember that the sample should have a change in color. Alright, so kailangan na siya color for it to determine the concentration of that certain chemical. So, for example, if you dissolve iron in water, so it emits blue light. I mean a blue color. So, if you subject it to the colorimeter, so it will have a certain wavelength. For example, it is at 570 nanometers. So that 570 you can correlate with the concentration of the iron sample. So how much iron would be there in that sample? So the meter measures the intensity of the color and calculates most values in parts per million. So parts per million is a unit for concentration as well. So how about the chemical factors? So first off is we have the pH. So we know pH is the power of hydrogen. So it is a measure of the increase of hydrogen ions in water. So additional carbon dioxide in fresh water can decrease the pH, making the water body more acidic. So if you add carbon dioxide in the water, it could form acids that will make the water more acidic. So runoff, including the addition of ions in water, is also important. So we have the phosphates, chlorides, and etc. that are dissolved solids. So to measure the pH, we have... So what are other factors? So we have the gases dissolved in water. So water can hold gases, but the amount depends on the temperature of the water. So as you can see here, so oxygen solubility drops as the water temperature of the water increases. Alright, so I've mentioned before thermal pollution. So if the water is very high in temperature, that could cause the oxygen solubility to drop as well. So that therefore affects the marine life or aquatic life. So I've mentioned earlier that adding CO2, dissolved CO2 in water could decrease the pH, making it more acidic. Now that is because of the CO2 forming carbonic acid, bicarbonate, and carbonates. Alright. So gases in water can be measured in concentration. So it could be measured in milligrams per liter as well as or ppm. So gases can be tested using different kinds of meters. But it could also be done through titration reactions. Now, titration for oxygen. So, dissolved oxygen is sometimes referred to as DO. So, dissolved oxygen meaning ang oxygen na dissolve sa water. Alright, so the titration method to measure DO is called the Winkler titration. Once you get to the fixed stage, it could be analyzed using a colorimeter. Alright, so gases could mean there is an increased CO2 and decreased. So let's move on to the BOD, or the biochemical oxygen demand. Alright, so BOD, from the name itself, biochemical oxygen demand. So I've already mentioned this from our previous topics. So this is the oxygen needed to break down the organic matter inside a water sample. Muna ang oxygen nga kailangan sa bacteria para makaon ang organic matter. So, 'di ba, bacteria or the microorganisms need oxygen to eat the organic matter. All right? So the BOD measures the amount of oxygen consumed by microorganisms as they decompose organic matter, as well as the chemical oxidation of inorganic matter. So the BOD test measures the amount of oxygen consumed during a specified period of time. So BOD 5 is usually done. So usually 5 days at 20 degrees Celsius. So muna siya ang standard na ginagamit most of the time. But then you could also measure BOD at different periods of time. So, BOD, the biochemical oxygen demand, while the DO is the amount of oxygen present in your water. So, DO is measured initially and again after a 5-day incubation at 20 degrees Celsius. So, a sample is taken at day 0. Then, DO is measured at that sample. By the end of the 5 days, the DO is again measured after incubation at 20 degrees Celsius. So, BOD is computed from the difference between the initial DO and the final DO. So, the rate of oxygen consumption is affected by a number of variables. So, there could be temperature change, pH change, and the presence of certain kinds of microorganisms. So, depende gyapon sa microorganisms na present and the type of organic and inorganic material in the water. Now, how do you calculate the BOD? So, when the water is not seeded, so meaning wala siya gibutangan o any seeds, now let's proceed to the BOD. Alright, so BOD calculation. So, let's say we have a water sample. So, sometimes ginabutangan na nila og microorganisms to help calculate the BOD. Sometimes dili na kay naa na siya microorganism on its own. So, when the water sample or the dilution water is not seeded, the formula for BOD or the 5-day BOD is D1 minus D2 over P. So, what is D1? So, that is the initial dissolved oxygen, while D2 is the final dissolved oxygen. But, when the dilution water is seeded, so meaning gibutangan siya og microorganism, so you can get the BOD from this formula, which is D1 minus D2 minus B1 minus B2 times the fraction of seeded dilution water volume in sample to volume of seeded dilution water in seed control over P, which is the fraction of water sample to the combined total volume. So, kaning P, letter P, which is the fraction of weight of the water sample to total combined volume, the water sample is diluted with water. That is why it is called dilution water. The water sample, gibutangan siya og more water to be diluted before siya gi-subject to incubation. So the fraction would be the weight of the water sample over the total volume of the sample. That would be the total water included plus the water sample. Alright? Okay. So that is for BOD5. So, or usually D1 or D1 and D5 or B1 and B5 or even B10, you can get the BOD. But how about calculating BOD at any time? So it is through this formula. So BOD at any time or BODT is equal to ultimate BOD. The LO is the ultimate BOD. So mo na siya ang BOD sa hangtod na. Mo na gyud na siya di na siya mo increase. That is the maximum BOD, ultimate BOD. Where T is also the time in days and K is the first order reaction rate constant. So K is a constant. Alright? Constant na siya. Alright? So it is 1 over day or it is per day. Alright? So the most important formula here is the last one, which is the LO times 1 minus e to the negative KT. So that would be all for the discussion. I've left some of the what you call this slides out of this discussion since it could already be studied by yourself. So you can do self-study on the things that I have not discussed, and I'll see you during the midterm exams. Thank you.